All right, good afternoon again, folks. Here we are looking at the 2.4 notes for writing linear equations. Again, the first form we looked at was slope-intercept form. Okay. Slope-intercept form of the equation of a line is y equals mx plus b, where m is the slope and b is the y-intercept. So if you look at the model here, okay, we've got a line, general line here, y equals mx plus b. We see that the point B, okay, comes from where this line intersects the y-intercept, the y-axis, excuse me. And that point is 0b. So if we had a line, let's say we had the equation y equals 2x plus 1. Okay, we know the point 0, 1 is on that line, and that comes from 0b because here we see this value of 1 is represented by b. Okay, and m is the slope. Okay, and we can use our formula for slope, and in fact we'll use this formula a lot, so we should write it down. M, or slope, equals y2 minus y1 over x2 minus x1. So we should be familiar and comfortable with able to use that formula. In fact, we use it a lot in 2-3, so we're going to continue using that. All right, so let's go ahead and move on. All right, so here we're asked in example 1 to write an equation in slope-intercept form for the line that we have graphed here. Okay, a couple of different ways to do this as far as finding the slope. The way they use the idea that slope is rise over run. So the rise of this one is -1. It's going down. So we say the rise is -1, down 1, and we can get to that next point. 1, 2, 3, 4. Our run is 4. So -1 over 4. That's rise over run. I think that's the easiest way to find the slope on a graph, is identify 2 points and then just do the idea of rise over run. Of course, the point 0, -2, well, that's where this line is crossing the y-axis, where it's intersecting it. So our y-intercept, or our value of b, is -2. So we have the slope, we have the y-intercept. We should be able to fill out our form, y equals mx plus b. That's our slope-intercept form, by just substituting -1/4 for m. And then plus b, so plus -2, just write that -2. Y equals -1/4 x minus 2. There's our answer. All right, so at this point, you would pause, okay? Go ahead, try both of these on your own, okay? In 1a, we are given the slope is equal to 4/3, and it passes through that point 0, 4, okay? It's useful for us to, if we look up at the top of that model again, if we have a point 0, comma, some value, we know that's going to be our y-intercept. So this should give us b is equal to 4. Okay, so we use y equals mx plus b again, substituting 4/3 for m. And 4 for b. That's our solution here. So again, try 1b on your own. 0, 6, we should be recognizing that kind of again as a 0, comma b point. Gives us that b value is equal to -6. Now this one doesn't give us our slope, okay, but it does give us 2 points, okay, and with 2 points we should be able to find our slope using that formula. Y2 minus y1 over x2 minus x1. We just got to label a point. So pick a point, call 1.1, 1.2, doesn't really matter. Okay, I'll go ahead and call this x2, y2, x1, y1. All right. So using those values, I've got 10 minus -6. So 10 plus 6 over -4 minus 0. So that simplifies to 16 over -4. just equals -4. That's our value of it. M equals -4. We've got b is equal to -6, so now we're able to write y equals -4x minus 6. That's the equation of a line that passes through 0, -6, and -4, 10. Okay, going to go ahead and move on. Okay, now we're talking about our second form for the slope of a line, or excuse me, our second form of an equation of a line, and that is point slope form. The point slope form of the equation of a line is y minus y1 equals n times x minus x1. Where x1 and y1 are the coordinates of a point on the line, and m is the slope of the line. So again, you see that y1, x1, that just comes from a point. Any point that is on that line. Okay, that point again would be the ordered pair. x1, y1. Okay, so we're just going to apply this. We're going to apply this formula here on a couple of examples. Okay, we use point slope form. Okay, when we're given a slope and a point, or enough information to find a slope at a point. Okay, but then oftentimes after we write it in point slope form, we want to change it to slope intercept form. Slope intercept form being the easier form to graph. So that's why we do that a lot. All right, but here we're given a slope. Okay, and we're given a slope of a line. We're given a point that the line goes through. So we want to use point slope form. Okay, point slope y equals m times x minus x1. That's the form we're using here. We've got a point. Let's call that x1, y1. So y minus y1, y minus -2, y plus 2 is equal to m is -4. X minus x1 is 6, so x minus 6. Simplifying this, we're changing it. This is in, again, point slope form. We want to change it to slope intercept form. Okay, we do that because it's easier to graph. So we need to distribute this -4x. We're solving for y. Slope intercept. So distribute the -x. We've got y plus 2 equals -4x plus 24. Subtract 2 from both sides. Y is equal to -4x plus 22. And that's the equation of the line in slope intercept form. This was the equation, y plus 2, this was the equation in slope form. Okay. So a lot of times we'll get it to point slope form and then we'll change it to slope intercept form. And that's in fact what we're going to do as you pause and go into these next two examples here, 2A and 2B on your own. Start with point slope form, go to slope intercept form. Okay, what that looks like. Again, we're going to start with that point slope, that y minus y1 equals m times x minus x1. This point is under x1, y1, of course. So we've got y minus 3 equals m, 1/2, times x minus x1 is 2. Distribute our half. Minus 3 equals 1/2 x minus 1. Just a little bit, run out of room. Add 3 to both sides. And we should get, I want to write up here, y equals 1/2 x, -1 plus 3 plus 2. Slope form and slope intercept form. M is 1/2, B is 2. All right, going to do the same thing here on this next example. Y plus 1, y minus y1. Minus -1 is y plus 1. Is equal to m, -3, times x minus -2, plus 2. Distribute our -3. Subtract 1 from both sides. We should get our equation in slope intercept form. Y equals -1/3 x minus 7. All right, as we go on to problems A and B down here, write an equation of a line given 2 points. All right, so we haven't done an example like this. Okay? Here we need to find the slope. We're not given the slope, so we need to find the slope. That's going to be the first thing we need to do. We need to choose 1 point and use point slope form. Eventually changing this to a slope intercept form. So let's go ahead and get started with that process. Again, the first thing to do is to find the slope. So label yourself x2, y2, x1, y1. Okay, so y2 negative 3 minus 7 minus y1 over x2 3 minus negative 2, so plus 2. That's going to be equal to negative 10 over 5. So slope equals negative 2. Okay, so we've got a slope. Now we've got a point. We've got 2 points. We can choose one of them. I'm going to choose x1 and y1 just for labeling purposes. I'm going to go y minus y1. y1 is 7. Y minus 7 equals n. We've solved for n. Negative 2 times x minus x1 minus negative 2 is going to become plus 2. Okay, so just substitute it in there to the points of slope form, the information that I have. Solving for y, trying to get this into slope intercept form, I need to distribute first. Add 7, and I get y equals negative 2x plus 3. Okay, I'll leave you guys be to do on your own. All right, so let's go ahead and look at parallel and perpendicular lines. Okay, looking at these, we need to just understand the main concept. Parallel lines, they don't intersect, okay, and their slopes are going to be the same. The slope of parallel lines is the same. And you see that here in the example given. Okay, we have the line y equals 2x plus 5, y equals 2x minus 1. Those lines are parallel and their slope is both 2. So parallel lines have the same slope. Perpendicular lines, however, are lines that intersect. Remember, perpendicular means they intersect at a 90-degree angle. Okay, that's what it means to be perpendicular. Okay, their slopes are what we call negative reciprocals. So let's call this line y1. We'll just label it 1 and 2. So slope 1 is equal to 3. Slope 2 equals negative 1/3. If we were to multiply those, they would, as in fact our book says, multiply to negative 1. Okay. What I want you guys to just understand is that we can we can flip the fraction on either of these, change the sign, and we've got the other. So I kind of refer to those as negative reciprocals. And I'll show you a little more in depth what that looks like here in an example. Write an equation in slope intercept form for the line that passes through 5, negative 6, and is perpendicular to a line with equation y equals negative 3/2 x plus 7. Okay, so here we got to make a little sense of this problem. We're talking about perpendicular lines. Okay, the slopes of perpendicular lines again are negative reciprocals. So what's that mean? Okay, the given slope is negative 3/2. Okay, so what do I need to do to find my slope? Or our slope, or the slope that's perpendicular, whatever you want. Okay, what I need to do is flip the fraction. Okay, so it's going to become 2 over 3. It was negative, so it becomes positive. So this is the slope we're going to use. N equals 2/3. Flip the fraction, change the sign. It's negative reciprocals. All right, so this is the slope we need to use for that perpendicular line. We've also given a point that's in our line, 5, negative 6, so we use point slope form. So y minus The y we're given is -6 plus 6 equals m. The m we found was 2/3. That's going to be perpendicular to -3/2. And then x minus x1, we'll use 5 as x1. A little bit of distribution. Y plus 6 equals 2/3 x minus 10/3. Subtract 6 from both sides. -10/3 minus 6. We common denominators. Let's do that here. 6, if we're writing that as over 3. Okay, it's going to be 18. So minus 18/3. 18/3 is equivalent to 6. So we've got common denominators, -10 minus 18, -28/3. You can also use your calculator. Well, that's going to be -9 and -9.3. Decimals. I would stick with fractions. It's a little more accurate. Okay, so that's how we approach perpendicular lines. They're going to have slopes that are negative reciprocals of each other. Let's look at our final example here. Parallel lines. Okay, parallel lines, we know that their slopes are the same. So if the line we are given, this y has a slope of 3/4, well, the slope we are going to use is the same, 3/4. Okay, so we need to use that combined with this 0.37. We're at the equation of the line. So y minus 7 equals 3/4 x minus 3. So y minus 7 equals 3/4 x minus 9/4. Add 7, so add 28/4. Your common denominators again. Y equals 3/4 x. -9 plus 28. 35% there. 19/4. Okay. First you use 0.75, or you use decimals. All right, so that finishes up your 2.4 notes. I know this was quick. Okay, this is just kind of meant to be an additional resource for you guys. If you do have questions, you got to come see me. So I'll leave you with that. Thank you. Have a good afternoon.